So yeah, welcome everybody. Thank you very much for organizing the weekly sessions and also this event today. We heard already earlier this morning great presentations about the influence of technology, or how technology influences or modifies humans, such as their decision making or their identity. But I personally, within this presentation, will rather focus on the opposite direction, more or less. So how can we humans shape the decision making of technology? And I think this also goes a little bit into the direction of what we heard earlier about, or what was mentioned about us wanting to operationalizing moral concepts. So I'm very excited what you're going to say to our approach. Yeah, I would like to present one of our research projects that I've been involved in, which is called ANDRE, Autonomous Driving Ethics. And yes, the ANDRE project is hosted and kind of funded by the Institute for Ethics and Artificial Intelligence at the Technical University of Munich. And how the projects always work is that we have kind of a always interdisciplinary teams, so at least 2 cooperation partners from different fields. So therefore also in our project we have on the one hand the chair of automotive engineering with Professor Lienkamp and Maximilian Geislinger, and then on the other hand we have the chair of business ethics with Professor Lütke and me as a researcher. And therefore also our research question lies exactly in the intersection between engineering and ethics, which is mainly how can we implement ethical decision making into the trajectory planning of autonomous vehicles. And in this regard, I would like to present some first results from a working paper that we are doing at the moment. So what we did there is we conducted a structured literature review, and in which we identified the advantages and disadvantages that were mentioned in regard to using or implementing different ethical theories such as deontological ethics or consequentialism into autonomous vehicles. In this process, during this literature review, we also came across other theories that are important, which we called rather practical theories, such as risk management. And what we're aiming at with this working paper is to provide a holistic overview and kind of evaluation of applying different theories into the logic of autonomous vehicles, and as a result derive a proposition of an integrated approach. I won't be able to share all the advantages and disadvantages that we identified, but I want to show you or give you a brief glimpse in our results or what we've derived. So what we learned from all the literature that we've read is that no single theory seems to be sufficient to meet all the social, moral, legal, or functional requirements. Instead, what scholars seem to be suggesting more so is that we need an integrated approach. But also what we found within the literature is that actually most of the theories can be practically implemented in some way or another into the functioning of autonomous vehicles. So for example, we can start off with, or what we could do is we can form a function in which we integrate different principles or theories. And how this could look like, I will show you in the next slide. But on top of this kind of function, we can include some kind of guardrails to limit whatever optimization would result from such a function. So for example, we can include rules or regulations which restrict the decision or the optimization process. So function XYZ can only be or may only be optimized if rule 1, 2, and 3 apply or are considered. And then also what we can on top include to this function would be kind of weightings or qualitative adjustments to adapt, for example, the strength of certain applied rules or ethical theories, or, for example, the strength of consideration for particular road user types. And then lastly, also what we can include on top of these optimization functions is kind of thresholds that must not be exceeded. And then how can we determine these rules, weightings, and thresholds? Within the literature, what was kind of mentioned is, of course, we can use descriptive ethics to kind of gain insights into people's moral preferences. But of course, I mean, they can be informative, but I also want to point to the argument that is often made that we should not take these preferences as face value and just implement them one-on-one to the functioning of a vehicle or a technology in general. Apart from that, we can also adapt contract theory approaches that inform us on what rules, weightings, or thresholds could be objectively agreeable to. This was like a very abstract kind of result from our paper, but I want to show how, like a first attempt, how this could look like or work in more detail. So this is a paper that we published in 2021. And as a main theory, we drew on risk management, because as argued already by many scholars, road traffic is not anything like the trolley problem, where there are certain life and death decisions, but road traffic is more about events and consequences that are uncertain. So it's about risk and therefore about estimated harm as well as collision probability. So we used risk management as a main framework for our idea. And then in our example of a potential risk cost function, how we called it, we then considered or integrated the following theories. So first of all, we included consequentialistic ethics, or the base principle, which states that an action is moral or good if the aggregated total utility is maximized. So in our case, the total risk for all traffic participants should be minimized. Then we also included the principle of equality, that is an equal distribution of risk among all traffic participants. And lastly, the maximum principle, which is a strategy to avoid the greatest possible harm, such in our case, for example, a fatal expected injury. Within this function, as you can see, we also included W, which stands for kind of a weighting factor, with which the corresponding principle then should be included in this calculation. And then the goal of an autonomous vehicle would be to choose the trajectory that minimizes the risk cost function. So kind of this would determine whether the autonomous vehicle selects the path A, B, or C. And to give a more like insights into what our next steps are within the project, we actually want to conduct an experiment and determine what a W could be, so what the weighting could be, the relative importance of particular principles. This is a simulation that my colleague Maximilian ran. On the left hand, you can see the trajectory that an autonomous vehicle would select that aims to minimize its own risk, which is actually also in line with a pattern that Google described in 2014. On the right, then you can see a trajectory of an autonomous vehicle that an autonomous vehicle would select that runs according to our risk distribution approach. And what you can see, and I hope it is visible, it's minor the difference, but still what you can see is that the selfish vehicle drives closer to the cyclist and thereby exposing the cyclist to more risk than in our approach. And therefore, I also looking at the time, I will come to my conclusion and the takeaways. What is very important to mention is that we don't want to make the stance that this approach that we are suggesting here is finalized or best practice approach. We rather kind of want to show that we can actually learn and rely on theories from ethics and philosophy in informing our programming. So we want to kind of set an example of applied ethics and how to turn ethics into code, what could be done. We want to draw attention to and show the difference that ethical programming makes for different traffic participants. So in our case, the cyclists in the figure I just showed. And lastly, we want to provide maybe a starting point for policymakers, because in 2020, the European Commission published a report on ethics of connected and automated vehicles. And in recommendation 6, they stated that dilemmas should be managed by through principles of risk sharing and common ethical principles, and therefore we thought maybe our approach could be one of this, like one of such a starting point. And with this, I would like to finish my presentation. You can find our Android project at the website of the EAI Institute, and thank you very much for listening.
Right. I'd have a short question. What in the explicit example of the car being further away from the bicycle on that highway, what do you think in your calculation was the determining kind of variable that caused this difference? Because like it is a slight difference on the picture, but probably a big difference in practice, especially as a cyclist. Mm-hmm.
So you mean in the simulation?
Yeah, what do you think? Maybe it's maybe not possible to reconstruct that, but what do you think was the determining variable that caused this?
I would imagine the estimated harm that is expected when hitting a cyclist. So because the kind of rationale behind why risk would be higher for cyclists is that if you expect a car to crash with another car, the kind of risks would be less severe if you expect a car to crash with a cyclist. So I think the estimate, not the collision probability was the determining factor, but the estimated harm was the determining factor why in our approach it shifted away from the cyclist. Because in the other approach, in the what we call selfish approach, the risk, what they considered is just the risk to the ego vehicle and not the other participants.
Okay, then we have another question.
I'll come up to the,
thank you.
the mic a little bit. So I'm just curious. You mentioned you had a 3 different functions. You had the sort of harm minimizing. You had the minimax. And you had the I forget what the third one was. But anyway, so my thought is I'm curious about how different you expect those to be relative to just the question of how the harm itself is estimated. So for instance, one of the things that I have in mind, I don't know if you've seen this, but they're the websites where they claim you're helping them train some kind of AI, but you go on and you have like all of these cases and you have to decide like, I'd rather have the car swerve into this lane where it will hit 3 people than this one that's hitting 1, but then you get into all these versions where it's like, this lane has like a pregnant woman and this lane has like 2 homeless people and a dog, and it just like it's just these crazy sort of questions. And so it just seems to me that they're part of what's really driving things in that kind of a case is just like how much harm you think is being done to each of these potential individuals, say a person versus a dog. I'm just curious if you thought about that at all.
Yes, so what we're trying is actually going away from these discrimination based on any characteristics of the traffic participants. The only characteristics that or types of road users that we want to consider is vehicle versus maybe pedestrian or cyclist. because there the expected harm would be higher maybe. And I think this is also what some scholars state, that you should make maybe some claims concerning the type of traffic user, because it also relates kind of to how much risk they bring into the traffic scenarios anyways. So we are not making any claims similar to the Moral machine experiment, or I mean, they didn't do the claim, but they assessed preferences concerning characteristics of the traffic participants, so whether they're old, young, or animals, or things like this. So therefore, we hope to make kind of, I mean, they called them the moral machine experiment. Maybe we are rather in the area of the ethical machine experiment that we are trying to conduct. And we, like, of course, we just want to make a few abstractions, because we also think that determining, for example, the age or the sex of traffic participants maybe wouldn't work technically anyways. So I think there are technical reasons and moral reasons why you shouldn't include personal characteristics of traffic participants.
Okay, one more question.
Thanks for the talk, that's really fascinating. But I'm curious, like, did you come to the conclusion that the integrated approach was the best approach because that's how we as humans react in similar situations? Say for example, when we're driving, or are you making the claim that actually this is the right moral behavior that we should have, right? That we should actually be all walking around with integrating various different moral frameworks together when we make decisions. So is this a claim of what we actually do, or is this a claim of what we ought to do, or both?
I think it's not what we, I mean, we earlier today we had a presentation about rationality and irrationality, and I think we humans rather act, especially in such dilemma situations, on intuitions rather than rationalization. So our approach is, I wouldn't say similar to the human approach, and we just want to provide one first kind of blueprint of how you can integrate the theories, but we don't want to state this is exactly these three principles are perfect and then you're done, and this was just the first step of visualization how this could work and why it would be important, because one of our reasons why we were so worried about this issue, because we talked to some experts in that autonomous driving, and they stated that safety is the only importance, and with this, but what I meant is to the ego vehicle and not other participants involved. So with this, we wanted to show safety doesn't mean explicitly fairness. So therefore, it is a little bit a normative stance that we're trying to make, but we want to be clear that this is not the final kind of version that we want to put out there and be like, this should be the algorithm that autonomous vehicles should start running on now.
Gotcha. So just quick follow-up. So that so I think I get it, which is like you're making the claim in this paper that really what you're trying to prove is that you can have a formula. What necessarily goes into that formula, you're saying is still up for debate.
I'm sorry, you were breaking up a little bit. I couldn't understand the question.
Okay, I suppose are you making, so is the paper making the claim of, hey, we can come up with a formula, but you would still say that there's more work to be done as to what should go into the formula? So what x plus y plus is still to be determined. Yeah.
So I didn't understand the whole question, but yes. So this is a first approach of how you could rely on text and philosophy to make up a formula. But what goes into that formula is to be debated, in my opinion.
Thanks.